Now, before we get into solver, let's give some names here. Units produced, production capacity, click and hold control and then do the highlighting. So that way non-contiguous range can be highlighted. So then on-hand production, demand, ending inventory. Okay, let's give those names. And then we have storage capacity also to be named. And then the cost. We will define this name. So we'll say total cost. Okay, let's go to name manager and check whether we have everything. Okay, so it looks like we have it. Okay, so now we'll go to solver and we want to now minimize this. And by changing cells is that, and our constraints are production must be less than or equal to the production capacity. We have to put the less than or equal to here for readability. We really don't need that for solver, but we need to add that for readability, which I will in just a second. And then on hand after production, that should be greater than or equal to demand. So that we will be able to meet the demand. And then ending inventories should be less than or equal to the storage capacity. So these are the three constraints. So now non-negative, we have to make sure that this is simplex LP. Now click solve and make sure that you found a solution. So now we're going to run a solver table for this model. Okay, so here's the solution, how many units you need to produce and what will be the total cost. Now let's do a solver table, and this solver table is going to be for so now we have the optimum solution for the production planning problem that involves multiple time periods. And suppose we want to do a sensitivity analysis solver table for the holding cost. So the holding cost as the input. Instead of 5%, what if it is different? Then would that make any difference in terms of the amount of ending inventories that we will have? Okay. And we want the maximum of the ending inventories as the output. We want to look at what will be the maximum level of inventory if the holding cost is different. So let's create maximum inventory in this cell. Okay, let's call this. You can use the max function of the ending inventories along the months 1 through 6. So this will give us the maximum level of inventory that we reach over the horizon. Okay, so now we are ready to run the solver table. So we run the solver table. It's a one-way table, and the input is the holding cost as percentage. So this is holding cost. And we want the holding cost to go from 1%, which is 0.01, all the way through 10%. Okay, right now it is 5%, so 0.01 through to 0.1, and in the increments of 1%, 0.01. And the output that we want is just the maximum inventory. So solver table is very versatile in that way because you can set up additional output. So we can derive secondary outputs from the model, and we can look at those secondary outputs that we set up ourselves. Okay, so now click OK. Now you see for different holding costs, okay, what will be the maximum level of inventory. So at 1% holding cost, we hit the maximum storage limit of 10,000. But if holding cost goes up to 2% and more, the maximum level of inventory we reach is only 5,000 units.